We have now reached the tipping point of a new computing era. Per NVIDIA CEO Jensen Huang, accelerated computing is the byword for the data center of the future. Huang gave some perspective for the rise and potency of GPU compute as it relates to AI models and the capabilities that are now in market. Given the insatiable demand for compute power to train AI models, he used $10 million as a benchmark, whereas not long ago, that money would buy you 960 CPU-based servers burning 11 gigawatt-hours of power to train one AI large language model. The same money would now buy you 48 GPU-based servers using about a third of the energy and with the capability of training a whopping 44 LLMs. Speaking in general terms about AI and the sudden pivot that may seem to outside observers to have come from the sky like a lightning bolt in terms of its impact, Huang posits that the industry has reached a tipping point that was met at the confluence of deep learning and distributed computing. Anything that has structure, we can learn that language, Huang notes. We can now apply computer science to so many fields that were impossible before. A key takeaway of that, the ability for AI to cross over types of information. The big breakthroughs that have rocketed AI to the public's consciousness may be easy to grok chatbots like ChatGPT, but cross-content type AI applications suggest an even more radical impact to transform text to video, video to text, or text to music. The NVIDIA CEO gave some visceral examples. In one, he put up a block of text that an AI instantly transformed into a seemingly real-world woman saying his words on video. In another demo, he generated a flow of atmospheric, Taiwan-themed traditional music simply from a voice prompt description of the kind of music he wanted to hear. Beyond that, he used a prompt to create the lyrics to a jingle-type song, which the AI then set to music and then enabled a differently generated version for the audience to use in a sing-along. Huang detailed the NVIDIA Avatar Cloud Engine, or NVIDIA ACE, for game developers. This tech is designed for developers to tap in order to generate and customize AI characters in-game. The character models are pre-trained and will come ready to generate dialogue based on backstories that the AI can draw upon to generate a sense of consistency and realism. The idea here is that ultimately, at the edges of a given PC game, non-player characters may be handled by AI-generated interactions like these rather than scripted progressions. NVIDIA's GH200 superchip, also known as Grace Hopper, is in production, Huang announced. Designed to support accelerated computing, the GH200 includes a 72-core ARM-based CPU, 96 GB of HBM3 memory, and 576 GB of graphics memory. Following from the Grace Hopper developments, Huang detailed the NVIDIA DGX GH200. It's a massively scaled-up supercomputer solution based on the GH200 for generative AI training and LLMs expected by the end of the year. Ultimately, 256 GH200 Grace Hoppers are connected in a DGX GH200. Groups of 8 are linked together via NVLink. Then, in turn, 32 of these groups connected via a layer of switches create in essence one big supercomputer-scale GPU, as Huang referred to it. A DGX GH200 will have 150 miles of fiber optic cable, have more than 2,000 fans, and according to Huang, weigh 4 elephants. This supercomputer promises to be a monster for generative AI applications. Huang showed off the first fruits of the Spectrum X initiative in the form of the Spectrum 4 switch, with 51 Tbits per second of bandwidth. The Spectrum 4 employs a massive die measuring 90 mm square and consuming 500 watts. Huang hoisted one to show off the sheer scale. For the very first time, we're bringing the capabilities of high-performance computing to the Ethernet market, he noted. It works with NVIDIA's Bluefield chips for network traffic prioritization. Deep into the second hour, there's the MGX server specification. NVIDIA announced this set of guidelines, which are a reference architecture for building servers suited to AI training and other high-performance needs. A host of major players in the server space are poised to get on board with MGX. MGX-based servers will outline basic computing architectures and then offer predefined variants for specific workloads in model training, design work, and edge compute applications. MGX-based server designs should start appearing later this summer from server stalwarts such as QCT and Supermicro.